This video is going to look at how we can find the complement and supplement in terms of radians. If you remember before in a previous video, we looked at how we can find the complement and the supplement working with degrees. We now want to look at that using radians. Well, remember when we were looking for the complement, we said that in terms of our degrees, this was two angles that add up to 90 degrees. So here, when we think of 90 degrees, well, we know that's the same thing as pi over 2, okay? So remember, here's our 90 degrees here at the top. This is the same location for pi over 2. And when we're looking for the supplementary angles, or we're looking for the supplement, we want to know what is the angle, the two angles that add up to 180 degrees. So if 180 degrees is all the way over here, we know that's the same thing as pi in terms of radians. So we're going to do exactly the same thing we did before with the radians, with the degrees, but now we're going to use radians. So if we look at the first example that we have here, if our angle theta is equal to, let's say, pi over 8, we want to find the complement and the supplement for this particular angle. Well, it's easy to find the complement. We're simply going to take the pi over 2 and subtract away pi over 8. And in order to do that here, we need a common denominator of 8. So if we multiply the 2 by 4, we multiply the pi by 4, so that gives us 4 pi over 8. And of course, we can see that's the same thing as pi over 2. And pi over 8 is going to stay the same because it already has the common denominator. So 4 pi over 8 minus pi over 8, we end up with 3 pi over, whoops, not 4, 3 pi over 8. So that is the complement. So if we were to add 3 pi over 8 and pi over 8, we would have 4 pi over 8, which is pi over 2. So pi over 8 and 3 pi over 8 are complementary angles. So 3 pi over 8 is the complement. So how can we find the supplement? Well, we could take and use pi and subtract pi over 8. So again, we need a common denominator of 8. So here we have pi over 1, so we're going to multiply the denominator by 8 in the numerator. So we would have 8 pi over 8, which would simply mean the 8's would cancel, which is pi. So 8 pi over 8 minus 1 pi over 8, then we would have 7 pi over 8. So obviously if we add 7 pi over 8, 1 pi over 8, we get 8 over 8, which is 1 pi. And as far as a visual there, we can know that if this point is pi over 8, and 4/8 is a half, so that means this is 4 pi over 8, so that's halfway there. And then if we go 5, 6, 7, or we can think of it even easier, that 1 pi is equal to 8 pi over 8. So it would be obvious that 7 pi over 8 is going to be here. Okay, so hopefully you notice this is the same thing we did with degrees, but here, instead of using 90 degrees minus the angle, it's pi over 2. And instead of using 180 degrees minus the angle, we're using 1 pi. All right, so let me give you another example. And once again, maybe you can pause the video to see if you can work this one out. Theta equals pi over 6. And once again, we want to find the complement and the supplement. Okay, if you did pause the video and you tried this on your own, hopefully you noticed something special when you tried to find the complement. That means we would take pi over 2. And if you notice this right off, maybe you didn't even go this far with it. But we take pi over 2 and we subtract away the 5 pi over 6. And if we get a common denominator of 6, then 3 times 2 is 6, so therefore we get 3 pi over 6. And here we have 5 pi over 6. And we notice now we can't subtract 3 pi minus 5 pi. We're going to get a negative value. So what that tells us is the 5 pi over 6, and you probably would have noticed this, is bigger than 1/2. It's bigger than pi over 2, so therefore there is no complement. And there's no complement because if we look at this, the angle 5 pi over 6, well, if we think of dividing this like we did before into 6 equal parts, 3 pi over 6 is the same thing as pi over 2. So that tells us that 5 pi over 6, you know, that's going to definitely be bigger, so therefore it's already bigger than pi over 2. So your 5 pi over 6 is probably close to this location here. Okay, so there is no complement. Well, can we find the supplement? Well, that means we're looking at here is pi, so we can take pi and subtract away 5 pi over 6. Well, if you think of this in terms of common denominator, then as far as 6, this would be the same thing as 6 pi over 6. So 5 pi over 6 to 6 pi over 6, you probably can tell then that this here is going to be equal to what? Pi over 6, right? So, and if you can't see that, we can get a common denominator. Here we would have pi over 6. So if we have to multiply this by 6, this would be 6 pi over 6 minus 5 pi over 6. And if we subtract, we end up with 1 pi over 6. But if you kind of think counting this off, 5 pi over 6, you know this distance here, the other complement here is going to be pi over 6. All right, one last example dealing with complements and supplements. What if I give you the angle 1.3? Can you find the complement of 1.3 and the supplement of 1.3? And once again, you may want to try this on your own. All right, now be careful. The 1.3, is this radians or degrees? Well, we know this is radians because if this was 1.3 degrees, we would have to have our little degree symbol. There's no degree sign up here, so therefore we know this is still in terms of radians. Okay? Now, this is an example where not always is your angle in terms of radians going to be what we call a multiple of pi. All the other examples we looked at up here above, our angles are in terms of pi. In other words, we're saying 5, 6 pi. 5 pi over 6, it's a multiple of pi. In other words, it's some fraction. In this case, it's a fraction of pi. It's a multiple of pi. Pi over 8. So here, our angle is a multiple or some part of pi. But down here, we simply have it as a decimal 1.3. So you're still going to do the exact same thing. If you're looking for the complement, it still has to add up to pi over 2. So pi over 2 minus the angle of 1.3. So then if we take the pi over 2 minus 1.3, we could certainly change the pi over 2 to a decimal. So we can go to the calculator, and we could see that if we take second function, and then over here to the far right is your pi key, and we would take pi divided by 2, and you could then simply, I'm going to hit enter just so we can see the decimal. So pi over 2 is the decimal 1.570796. So we could simply take that number, that decimal, and then subtract away the 1.3. Okay, so if we do that, then minus 1.3, and we hit enter, we get approximately, we'll say 0.27. So then that's our answer. And again, we're going to use kind of the squiggly here. This equal sign means approximate. Okay, so it'd be approximately 0.27. So that would be the complement. If we want to find the supplement, then we would take our pi and subtract away the 1.3. And now we know pi is approximately 3.14, or once again, we can go to the calculator, second function over here, hit for pi, and we want to subtract away 1.3, and we get approximately we'll go to two places, 1.84. So therefore, the angle is 1.84. Now, once again, we know this is in terms of radians because we're not going to put a little degree sign here. Otherwise, it's in terms of degrees. But because we're working with radians, we have 1.84 radians. All right, so hopefully that gives you a good review of how to go about finding the complement and the supplement. Again, if I was to give you the angle here, let's say that we had this particular angle of 73 degrees. Well, now if we're looking for the complement, recall, then we would use 90 degrees minus 73, okay? And we would use, for the supplement, we would take 180 degrees minus 73 degrees. So here, if we do not see the little degree symbol, we know that we are in radians.